Hi, this is Nancy Mansell coming to you from C&M Behind the Glass. Let's talk about adding radicals. 4 times the square root of 2 plus 3 times the square root of 2. You know what? That square root of 2 is a lot more like a letter than it is like a number. So what if it was actually 4x plus 3x? What would you do? You would keep the x and you would add the coefficients. So 4x plus 3x is 7x. It's the same thing for this radical. 4 times the square root of 2 plus 3 times the square root of 2 is 7 times the square root of 2. Those are called like radicals, very much like terms when you're adding with variables. Okay, let's have a look at this one. This one doesn't have like radicals, but perhaps using our techniques for simplifying radicals, we can turn them into like radicals, and therefore we can add them. Let's see. So what I'm looking for is I'm looking for a factor of 24 that is a perfect square. And one comes to mind, that would be 4. So let's break it down to 3 times the square root of 4 times the square root of 6. And what about the other one, 54? Does that also have a square root factor? It does. 9 is a perfect square. So let's break that down to 9, square root of 9, times square root of 6. You see where we're going with this? The square root of 4 is 2. The square root of 9 is 3. 3 times 2 is 6 times the square root of 6, plus 3 times the square root of 6. So now that we have like radicals, we can keep the radical and add the coefficients. And we end up with 9 times the square root of 6. Okay, let's try another one. I've got one up here for us. Square root of 12 times the square root of 75. Again, we're looking for perfect square factors. 12 is 4 times 3. So we'll break it up into 2 parts. 75 is 25 times 3. Okay, so why did we do this? So that we can take the square root of 4 is 2, and the square root of 25 is 5. So we have 2 times the square root of 3 plus 5 times the square root of 3. And now that we have like radicals, we can keep the radical and add the coefficients. And we end up with 7 times the square root of 3. One more. Let's see. 2 times the square root of 20x minus the square root of 45x. So we're going to take this and we're going to break it into parts, perfect square part and whatever's left. 4 is a perfect square. If I divided out a 4 from here, what would be left? 5x. 9 is a perfect square. If I divided 9 into 45x, what would be left? 5x. Very good. Okay, now let's take those perfects. 2 times 2 is 4 times the square root of 5x minus 3 times the square root of 5x. And 4 times the square root of 5x minus 3 times the square root of 5x is simply the square root of 5x. Why didn't I put a 1 in front of it? Can I? You can, but it makes you look like an amateur if you do that. So let's not. Pretty easy.